All right, I think this lesson's pretty self-explanatory. Hopefully we would have done this in class if we were in person, right? We have these dots, we put them out on these environments, and we start with 10% of each color of 10 dots. And as we go through time, go through one generation after the next, the population shifts to these different colors, and the colors end up being really good match for the background, right? And that is a nice simulation of natural selection. Some fun things to think about with this with these simulations of natural selection is that if we did this 100 times, we'd end up with basically the same results. Sometimes people will claim that evolution is random. There are components to evolution that are random. Mutation is random. But there are significant portions of evolution that are not random. Natural selection is not random. Natural selection is based on what is environmentally best. And this is actually what Darwin saw as he was traveling the world. And he actually came up with his initial idea by looking at domesticated species. We can create all different varieties of pigeons. Google it sometime. Crazy looking creatures. Think about a Chihuahua versus a Saint Bernard, right? They look wildly different. One looks more like a rat than it does a dog. All of these things were caused by humans deciding who would get to reproduce. And his idea was that if something could stop a segment of the population from surviving, or if something could help a population survive better, it would then result in that organism, that part of the population, reproducing at a higher rate, just like human interference caused some of these creatures to evolve or to reproduce at a higher rate. And his idea is that, well, if those were the ones reproducing, the next generation is going to look more like it, and then the one after that more like it, more like it, more like it, until everybody looked like that. And that was his idea, that all these organisms could have ended up being, they just seemed to match their islands that he was visiting so well. And that was his way of explaining it, by taking his background and understanding of artificial selection and human breeding programs for animals, and applying that to the way that the natural environment could work. Now, I want to tie this back to our logistic growth. I mentioned that if you have a growth rate of over 1, you're going to shoot up over the carrying capacity. And that's going to mean that some individuals are going to die and not get a chance to pass on their genes. And some still will reproduce. When you're over the carrying capacity, though, is it random who dies? No. The ones that die are the ones that are worse at dealing with whatever that limiting factor is. And the ones that survive and then reproduce, those are the ones that are better at it. And you go back down below the carrying capacity, and then it goes back over the carrying capacity. And the same process happens again, and then it goes back down and then back up. And you have thousands and thousands of years, hundreds of thousands of years of this process, this cycle happening. You're going to become really fine-tuned to dealing with your limiting factors. That population is going to shift and become better and better and better at dealing with those limiting factors. And so that's why we jumped into population growth, because we wanted to understand that population growth creates competition with dealing with those limiting factors, and that competition will result in natural selection and ultimately evolution. There's a few ways that that populations can shift as they evolve. If we think about a population as a normally distributed phenotype or physical appearance, right? We could have a shift towards one extreme, right? And that's directional selection. We either get one trait becoming more common or the other trait more common. Population can shift that way. We can have what's called disruptive selection, where either extreme is good, but being in the middle is bad. And that can cause the population that starts out as this to kind of move to be more like this. And so that's disruptive or diversifying selection. In contrast, you can also have stabilizing selection, where something in the middle is better, right? Either extreme is bad. And so you get this shift towards, instead of a nice curve, we get a shift towards everything being really similar to one another. That would be stabilizing selection. And there are examples of each in different environments, just depending on the characters of the organism and the selective pressures of the environment, the limiting factors that are there. We'll talk more about natural selection next week, but